When astronomers talk about our galactic neighborhood, they focus on the two giants, Andromeda, the largest, and our own Milky Way. But there's a third member of this cosmic family that deserves just as much attention. The Triangulum Galaxy, also known as Messier 33, is the third largest galaxy in the local group. It's a beautiful face-on spiral, oriented perfectly so we can study its structure in exquisite detail. At 273 million light-years away, it's one of the most distant objects visible to the naked eye. And it holds secrets that are changing how we understand galaxy formation, star birth, and the dynamics of our cosmic neighborhood. This is the story of the Triangulum Galaxy, the overlooked giant that's finally getting its moment in the spotlight. Why study Triangulum? 3 reasons. First, its orientation. It's almost perfectly face-on from our perspective, giving astronomers a clear, unobstructed view of its spiral structure, star-forming regions, and the distribution of stars and gas. Second, it's different from its larger neighbors. Unlike the Milky Way and Andromeda, which are barred spirals, Triangulum has no central bar. Its arms emerge directly from its core. And third, it may hold clues to a fundamental question. Why do some galaxies have supermassive black holes at their centers, while others apparently don't? In this documentary, we'll explore every facet of the Triangulum Galaxy, from its discovery by a little-known Italian astronomer in the 1600s, to the latest Hubble mosaics revealing 25 million individual stars. From its massive star-forming region NGC 604, 40 times larger than the Orion Nebula, to its mysterious lack of a central supermassive black hole. From its possible status as a satellite of Andromeda, to the stream of hydrogen gas that connects them. This is the complete story of the third giant of the local group. The story begins in the 17th century with a little-known Italian astronomer and priest named Giovanni Battista Hodierna. Before 1654, he published a work called De Systemate Orbis Cometici, in which he listed several nebulous objects he had observed. Among them was a cryptic entry, near the triangle Hinc Inde, a reference to the constellation Triangulum. Most historians believe this was the first recorded observation of the Triangulum Galaxy. For nearly 150 years, this discovery remained obscure, known to few. On the night of August 25, 26, 1764, the French astronomer Charles Messier was doing what he did best, searching for comets. He kept finding fuzzy objects that could be mistaken for comets, so he decided to catalog them to avoid confusion. On that night, he independently rediscovered Hodierna's object and added it to his list as entry number 33. The name M33 stuck. Messier described it as a nebula without stars. His telescopes weren't powerful enough to resolve its true nature. When William Herschel compiled his massive catalog of nebulae, he generally avoided including objects already listed by Messier. But M33 was an exception. On September 11, 1784, he observed and cataloged it as HV17. More importantly, he noticed something within the galaxy, an unusually bright patch that he cataloged separately as H3 150. This patch would later receive its own NGC designation, NGC 604. Herschel had discovered the most spectacular star-forming region in the local group without even knowing it. In the mid-19th century, Irish astronomer William Parsons, the 3rd Earl of Ross, built the largest telescope of his era, a 72-inch reflector known as the Leviathan. With it, he observed several spiral nebulae and made detailed sketches. In 1850, his assistant R.J. Mitchell produced a drawing of M33 showing its spiral arms. Mitchell described it as full of knots with 2 similar curves like an S cross in the center. This was among the first evidence that some nebulae had spiral structure, a clue that they might be separate island universes like our own Milky Way. The early 20th century saw the great debate over the nature of spiral nebulae. Were they gas clouds within the Milky Way or separate galaxies entirely? In 1922-23, astronomers John Charles Duncan and Max Wolf discovered variable stars in M33, but it was Edwin Hubble who delivered the decisive blow. In 1926, he identified 35 of these variables as classical Cepheids, stars whose intrinsic brightness varies in a predictable way with their pulsation period. By measuring their apparent brightness, he could calculate their distance. The result was unambiguous. M33 was far beyond the Milky Way. M33 was an independent stellar system, an island universe. The debate was over. In the Hubble classification system, Triangulum is designated SAS.CD. Let's break that down. The S means it's a spiral galaxy. The A indicates it has no central bar, unlike the Milky Way and Andromeda, which are barred spirals classified as SB. The S means the spiral arms emerge directly from the nucleus rather than from an inner ring, and the CD suffix places it at the open end of the spiral sequence, meaning its arms are relatively loosely wound. One of Triangulum's greatest gifts to astronomers is its orientation. It's tilted at an angle of about 54 to 56 degrees to our line of sight. That's nearly face-on, giving us an unobstructed view of its spiral structure without significant obscuration by gas and dust. Unlike edge-on galaxies where spiral arms are hard to trace, Triangulum presents its full glory for us to study. It's the perfect laboratory for understanding how spiral galaxies are structured. Lord Ross's 19th century sketch described M33's arms as two similar curves like an S-cross in the center. Modern images reveal far more detail. The arms are thick and clumpy, dotted with blue star clusters and pink nebulae. The arms are less tightly wound than those of Andromeda or the Milky Way, giving the galaxy a more open, relaxed appearance. At the center of Triangulum lies a bright nucleus, classified as an H2 nucleus because of its ionized hydrogen emission. But here's the surprising part. Unlike most large galaxies, Triangulum lacks a central bulge. It also lacks a supermassive black hole at its heart. The core region is simply the innermost part of the disk, with stars orbiting in a relatively flat plane rather than a three-dimensional bulge. Like many spiral galaxies, Triangulum's disk isn't perfectly flat. Out to a radius of about 26,000 light-years, the disk is warped. This warp is likely caused by gravitational interactions with other galaxies. The warp is subtle, but it tells us that Triangulum is not an isolated, undisturbed galaxy. It's feeling the gravitational pull of its massive neighbor, Andromeda.